PC Calculus, Lesson 10.4, Radius of Convergence. So, this has been a humongous chapter with tons of stuff tucked in. We're trying to tie it all together. A lot of this chapter, a lot of this unit, this lesson, does things that just, make sure you know what you're talking about. A series that converges is a number, which is a tough thing to understand. It's not a sequence, it's a series. We're summing them all up. One that diverges, for lack of a simple way to put it, is not. It's something else. So we got to be careful with equal signs. I mean, this is just a quality of, some real numbers. This is just a quality of a couple of expressions. This is an equation. It's like an open sentence, because we don't know if it's true. We have to solve it to make it true. And we could have an equation like 5x plus 7 equals 5 parentheses x plus 7, which has no solution. So you never know. And this is sort of an identity, because if you factor the top, do all that sort of thing. But it's got conditions. And in this case, the condition is x cannot equal negative 1. If that happens in the original one, it's undefined and not equal. So here's the sentence. 1 over 1 plus x squared equals yada, yada, yada. This is a geometric series, which is the first thing we should worry about today. If we know it's a geometric series, then we say, oh, it's 1 over 1 minus something. In this case, that's negative x squared equals 1 minus x squared plus x to the 4th minus dot, dot, dot. We'll define the interval of convergence, also known as what values of x this is equal for. And from here on out, I'll just say IOC. You have to say that negative x squared has to be less than 1, because we know from a geometric series that it has to be less than 1. We've played with this a little bit before. Absolute value gets us to x squared. Square root of both sides gets us back to absolute value. If we solve this, we get negative 1 is less than x is less than 1. And that's our interval of convergence. We can also start with something called the radius of convergence. What happened to my IOC? Radius of convergence, which we'll say is r, and in this case it equals 1, because it is centered at 0, and it goes 1 either way. Seems kind of loopy, but whatever. Geometric series are easy, as we just said. What about non? Well, now we get into a bunch of theory, for lack of a better way to put it. So here's the 3 possibilities. We get convergence for everything. That's this one. Convergence for a certain interval, like the last one. Or it only converges at the center. So it always converges somewhere, but it diverges everywhere else. That's that one. So let's go find out how we check. Like I said, R is called the radius of convergence. Excuse me. And the interval is everything inside. So we've got some tests. Let's do the nth term test. We just take the limit as n approaches infinity, and if it's not 0 or it doesn't exist, then okay, the series is going to diverge. You know, it has a center at r equals 0 or r equals a. So let's just throw one up there. We'll try x minus 2 over n over 10 to the n. I was going to say that didn't make any sense. And as we go to infinity, we notice that both of these go to infinity. So we'll do a little L'Hopital's rule. And we get n times x minus 2 to the n minus 1. I have to stop and think. I feel like I'm doing this wrong. Oh, I am doing this wrong. Sorry, I need to use a different setup. Let's try one with I'm a little trouble here. Give me a second. Lost my example. I don't know what I did with it. Okay, sorry about that. Let's do the one we're going to use later. We'll use a slightly different one. X to the n over n factorial. What's the limit as n goes to infinity? You should know this as 1 over some really huge number, which is 0. Because a factorial grows faster than an exponent. Should have gotten that from the previous lesson. So that's one test, nth term. Notice the nth term only tells us if it diverges. It's not 0, diverges. If it converges, then it's 0, and what's the interval? Well, we need a different test for that. Direct comparison test is similar. It's only going to show us if it converges. You can read the definition if you'd like. For me, it's easier to just do an example. So you rewrite this as x to the 2n. Not rewrite it, you just write it again, n factorial over squared. And I know this is going to be less than or equal to x to the 2n over n factorial. Think about that one for a moment. This one will have a bigger denominator because it's being squared and n is positive. So it's definitely going to be smaller. This, by the way, is equivalent to, and if you know, this is just the formula for e to the x. And in this case, it's e to the x squared. And I happen to know this converges for all real numbers. So if e to the x squared converges, then so does this. I'm not a big fan of the direct comparison test. But notice that all those terms are positive and the non-negative aspect pops up. This is just a definition. It pops up a little bit later. You don't have to worry about it. But if I know that it absolute value converges, then I can say that it converges. And they go through this little ticky-tacky nonsense. If the absolute value converges, we say it converges absolutely, meaning it'll meaning what it says. If the absolute value converges, then it converges absolutely. That's just a word for definition. I got a little hung up on the word absolutely, like that means something massive. It's just the way they say it. By the way, if it converges absolutely, then it converges. A lot of roundabout way, and it pops up in definitions. But this one we say, well, I know that the absolute value sine of x to the n over n factorial is less than or equal to 1 over n factorial. which again converges to E, which is something that converges so we can use that, and it converges absolutely and all that nonsense. Let's get where I've been trying to get for 10 minutes now. Ratio test, because not only does this tell us if it converges or not, it tells us what the interval of convergence is by using this concept of L. So we're going to put n plus 1 in and divide it by the term with just n, and I'll show you how that works. And we see what we get. If it's less than 1, converges, we can find the IOC. If it's greater than 1, diverges, and the IOC is, the radius is 0. If it's equal to 1, it's inconclusive. And that's tricky stuff. Another time on that. So this finally gets us to radius convergence. So here's how we do it. Limit as n approaches infinity. On top is n plus 1. Always put it in absolute value. Over 10 to the n plus 1. I'm going to erase this. We're dividing by n, x to the n. So I wouldn't write this down because we just flip it. 10 to the n and x to the n. Put together pieces that look like each other. N plus 1 over n. That's going to go to 1 as n goes to infinity. 10 over 10 to the n over 10 to the n plus 1. That's going to go to 1/10. And x to the n plus 1 over x to the n. That's going to go to x to the n. So we end up with x to the n over 10. And I look at that and I say, well, I don't know if that's greater than less than 1. And we say, no, we're assuming it converges because they're saying what's the radius convergence. Or that it has a radius that equals 0. Another time coming up soon. It's a different question. So read those questions carefully. Hey, does this diverge converge? Well, let me check. What's the radius convergence? Oh, it converges. This has to be less than 1. We do a little math. We get the absolute value of x. There's no n up here. My apologies. Has to be less than 10. Therefore, the interval of convergence is from negative 10 to x to 10. And the radius convergence is 10. 0 to 10 or 0 to negative 10. Complex stuff. Rewind. Watch again as needed. Radius convergence of this series. N plus 1. I forgot my limit. Factorial. Absolute value x to the n plus 1. This one we can just straight divide. There's no fraction, so n factorial x to the n equals limit that approaches infinity of n plus 1 absolute value of x to the n. Keep putting that in there. I don't know why. As n goes to infinity, this goes to infinity. So there is no interval of convergence. It only converges when x equals 0, which seems kind of weird. And it converges to 0 in that case. So we say r equals 0. Which basically means it does not have a radius convergence, but hey, that's how those calc maniacs do this. So the ratio test is really a test for absolute convergence. This is what we messed with before. It establishes the radius convergence for some term centered at A. So what's going on at the endpoints? Next lesson. We're going to mess with a few other things now. Determine the convergence or divergence of the series. Well, we can do this in two different ways. We can use the nth test, because it's just asking, does it converge or diverge? So we say, what's the limit as n approaches infinity of 3 over n over 5 over n plus 1? They both go to infinity, so we take the derivative, n 3 to the n minus 1 over n 5 to the n minus 1. N's cancel, gives me 3/5 to the n minus 1. The limit of that is 0, so that tells me converges. What's the interval of convergence? Don't know. There is no interval in this one when we don't have an x. So if it converges for everything, because there's no x value. Ratio test, a little trickier. Limit as n approaches infinity, 3 to the n plus 1, 5 to the n plus 1, 5 to the n, 3 to the n. Gives me 3. And eventually, I'm skipping on the math here, 5. This is less than 1, converges. If you need to go back and figure out how I got from here to here, go look at your limits. I could have used L'Hopital's rule. I could have done all sorts of things, but I'm cutting to the chase, running out of time. How about a telescoping series? And you'll see why we call it that in a minute. Well, this one's pretty cool. We got to do a little bit of partial fractions. And what's the question here? The sum. What's it converge to? This is going to equal 1 over n plus 1. So you got to do all this nonsense. A times n plus 1 plus b times n equals 1. Let's put in n equals 0, a equals 1, n equals -1, b equals -1. So now I can ask the question again. What's the limit? No. What's the sum? One over n plus -1 over n plus 1. Let's do some partial sums and see where it takes us. Put in 1, we get 1 over n, 1 over 1 plus -1 over 2. Now let's add number 2. 1/2 plus -1/3. Now put in n equals 3. 1/3, -1/4. 1/4, -1/5. Take a look. We get 1, and they cancel, they cancel, and they cancel, and they will cancel ad infinitum. The sum equals 1. So that's a telescoping series. It's a unique situation that you can do that with. That's a boatload of math. Definitely wish you best of luck and happy mathing.